Thank you.
Take it away.
Hey, hi. Where's the clicker thingy?
Clicker is here.
Yay. Okay, thanks. Yeah, it's really interesting to see how many companies are generating data, and that's going to be fantastic. I'm going to tell you, well, 2 observations, 1 story, and then I'll tell you what I'm actually doing. So, I'm Smari McCarthy. I'm founder of Ecosophy, based in Iceland. And this is a map from the 1620s, and I don't know if you can read at the top here, it's in Latin and it's small, but it says, new and very accurate map of the entire world, right? And so, when data doesn't get updated, the past starts to misinform the present, right? This is a picture from when I visited the land management office in Nangarhar County in Afghanistan in 2009. And well, so these are all land records, the deeds of all of the land. When data is hard to access, hard to read, and hard to update, then the policy that gets made on the basis of that starts to have the past basically control the future. So, I used to be a member of the Icelandic Parliament. I'm a techie at root, but I accidentally founded a political party, long story. But at some point I was looking at climate policy, and people kept bringing to me all these proposals. We should spend this many billions on this, or this many billions on that. And I kept saying, where's the data? How do you back up this observation, this plan, with something meaningful that I can trust? And the answer turned out to be, there is no data available. Except that wasn't entirely true. The data turned out to be available, but the people whose job it was to use the data to make the policy, they didn't have access to all of the data that was being produced by all of the wonderful data providers. So the current way that people do things is they sit down and they write lots of Python code, and then or R code or what have you, and then they'll throw up some kind of image like this. This, by the way, is the Arctic sea ice extent 70 years after the collapse of the Atlantic overturning oscillation, just in case you want something to have nightmares about. But, this is basically the way people do things. And people whose job it is to make policy don't have time for this. Also, if you want to fetch the most recent data, this is the type of thing you need to do. You need to go through, find the right data set, and then, get this kind of thing, and then you need to copy that and paste it and do all sorts of madness. That, again, policymakers and people whose job it is to make decisions don't have time or necessarily the technical skills to do, right? And so the problem is that the common analysis tools often require coding skills or deep technical knowledge, and that is not okay. There are, of course, some good tools out there, but they tend to be very, very specific for very, very narrow use cases. And there are, thankfully, more and more common use solutions. I decided to quit politics and start Ecosophy and start building EarthOS as a generic system to take data from all of these different sources, whether that's climate models, satellite data, or any other type of thing, and harmonize it. But, very importantly, start to ask the question, what if all of the maps are always new and very accurate? And what if we could start to query the entire planet fast? And so we did an experiment. We got a bunch of oceanographers and asked them a very simple oceanography question, and they could choose which data set to query and such. Took them on average about 2 weeks to find the answer. Then we let them loose on our system, and they could find the answer in a matter of minutes. Should have been seconds, but they were new to the system. Our entire concept was pull in all of the data, harmonize it, make it really, really easy to query using essentially a kind of algebraic query language. We'll make it easier still in the future, but then start to build tools on top of that that fit into different use cases. And the big thing here is being able to pull petabyte scale data and start to resolve arbitrary queries about the entire planet or any subsection thereof in milliseconds. That's really the important thing, because people whose job it is to make decisions don't have time to wait around for weeks on end for answers to simple questions, right? So we were originally thinking, okay, climate change, that's the big thing. But the moment you have this kind of tool, you can start using it for monitoring and modeling all sorts of scenarios, even mitigating scenarios by looking into the future, looking at forecasts, that kind of thing. Or planning adaptation and recovery, which is really useful if you're trying to not just say what might happen, but also how are we going to deal with it when it does, right? And this is all well and good, but then now happened, and somebody started asking the question, what is it about our software that is climate-centric? And the answer is nothing, really. We've really just built a really, really, really fast database for doing spatio-temporal queries. And so if we can query weather or climate or any combination thereof in milliseconds anywhere on the planet, could we then take real-time data about ships and aircraft? Could we pull in radar data or other data sources that were relevant to national defense? And the answer is, basically it's the same tooling, right? So we are now thinking, okay, let's pull in all of this historical, this real-time data, this prediction data, and basically not just be a climate change platform, but be a strategic intelligence platform for whatever use case. Now, obviously our roots are still in the climate space. We'd like to see progress there. We don't want everybody to be distracted with current events. But current events are pretty distracting, I think we can all agree. So the other thing is, by enabling all these different actors with all these different assets to start to coordinate and make decisions faster and better and in a more informed way, then we might be able to start combining information domains that are traditionally thought of as incompatible. So industrial information, supply chain information, how is this all affected by weather? If there's a storm that's slowing down a ship, what are the upstream effects on cargo shipping? That kind of thing. If there's a crop failure in a particular part of the world, what does that mean for food security elsewhere in the world? How does that play into, say, national unrest and other factors like that? Can we build a kind of generic modeling tool that allows us to understand the world with greater depth than we ever have before? The answer is yes, and we've made a little bit of headway on building it. So unfortunately, I can't really show you all of the really fun things because the last few weeks have been very exciting and lots of new things happening. I can maybe talk privately about some of it later. I'd love to chat with people, but essentially big things are coming soon for Ecosophy, and I'm looking forward to telling you more about it. So thanks.